So in this video, we're going to continue our discussion about asymptotes of rational functions. And so and specifically, we're going to talk about what's called an oblique asymptote today. But let's start off with a little bit of review here. Recall that a horizontal asymptote tells us what value our function approaches as x goes to the far right, so think positive infinity, and as x goes to the far left, negative infinity. So it's end behavior. We've talked about that before, right? So it tells us the end behavior for rational functions. And so if you recall, we said if the degree of the numerator is larger than the degree of the denominator, we say that there is no horizontal asymptote. And for an example here, I show you here y equals 3. So remember when we talked about horizontal asymptotes, we say, does it approach a flat horizontal line, right? However, it turns out that if the degree of the numerator is exactly one more than the degree of the denominator, we still don't have a horizontal asymptote, but what we have instead is what's called an oblique, or sometimes it's called a slant asymptote. All right, so the difference is, real quick, if I could draw it here. When we say we have a horizontal asymptote, let's say it's y equals 3, what we're saying is if you consider the graph, all right, and we say the horizontal asymptote is at y equals 3. So let's say y equals 3 is this mark here. This is what we mean by a horizontal asymptote. What we're going to talk about today is an oblique asymptote. Let's say it's going to be, instead, it's going to look something like this. All right. So we're going to focus today on how do we find the oblique asymptote. So that being said, let's jump into an example here. Let me switch colors. All right, so suppose we have the following function. Let's say f of x is equal to 2x squared plus 3x plus 5 all over x plus 1. Okay, our job here is to find the oblique asymptote. Okay, so we can see that we are precisely in that category of the degree of our numerator is 2, right? The degree of our numerator is 2, and the degree of our denominator is an understood 1. So the degree of our numerator is exactly 1 more than the degree of the denominator. So how do we find the oblique asymptote? You must use polynomial long division. So I'm sure it's probably been a while since we've seen this, so let's go through it. So to do polynomial long division, what we do is we take our denominator, x plus 1, and that's going to be what's called the divisor. That's going to be outside. And inside the house, we call this the dividend. We're going to put the numerator, 2x squared plus 3x plus 5. All right. So now, how do we do this? So what you do is you look at your divisor, you look at that first term in your divisor, and you say, what do I multiply x by to make it into a 2x squared? Well, that answer is going to be, here, let me switch colors here. That answer is going to be 2, right? So 2 times x gives me 2x squared. So if I put a 2, excuse me, oh, where am I? Let's go blue. Actually, it's a 2x, right? So if I multiply x by 2x, that gives me a 2x squared. So what I'm going to do is I'm going to put a 2x up here. And similar to long division, we now take the 2x and multiply it by the divisor, the x plus 1. So 2x times x is 2x squared. 2x times 1 is a plus 2x. And just like you did with regular long division that you learned way back in the day, we need to subtract these, all right? And so remember, we have to distribute the negative to everything that's in the blue here. So let's go ahead and subtract those. And we're left with 2x squared minus 2x squared, leaves us with 0, just like we want. Then we have a 3x minus 2x, which leaves us with a 1x. And then we bring down our plus 5 that remains in that dividend there. Okay, Now we play the game again. We ask ourselves now, what do we multiply x by to get back, well, x? Well, that's 1, right? 1 times x is x. So we're going to put a plus 1 up here and do the same thing. 1 times x, we're multiplying it by the divisor, is x. And then 1 times 1 is plus 1. And just like before, we're going to subtract that entire quantity. And we are left with, let's see, x minus x is 0. 5 minus 1. I'm just going to be 5 minus 1. That leaves us with 4, a positive 4. And the way that we write this remainder, guys, is that we say it's plus 4, and then you put it over your divisor, over x plus 1. Okay? All right. So our answer, which is called the quotient, right, is 2x plus 1 plus 4 over x plus 1. Right? So let's rewrite that. Let me come over here. Let's rewrite that. So we have so far an answer of 2x plus 1 plus 4 over x plus 1. But remember, for asymptotes, specifically horizontal asymptotes, we're looking at what happens whenever x goes to positive infinity and when x goes to negative infinity. And we've talked about this before in previous discussions that, hey, this part right here, right? As x gets really, really large, this part is actually going to tend towards 0, right? Goes to 0 as x goes to either plus or minus infinity. So because of that, our oblique asymptote will always be just this part of your quotient. Your oblique asymptote will never have a remainder in it. So our oblique asymptote for us will be y is equal to 2x plus 1. All right. So I hope that helps you understand a little bit about oblique asymptotes and how to find them.